You owe a friend $5. Your balance is -5. That feels normal today. But for centuries, many mathematicians refused to call negatives numbers at all. How can you have less than 0 apples? How can you count what is not there? And yet trade, temperature, and elevation all demanded a way to go below 0. The fight was long. Most people guess negatives are just a notation trick, a minus sign for subtraction, not a real quantity. The math says otherwise. -3 is a position on the number line, 3 units left of 0. It is the answer to what is 2 minus 5. Dead is not a metaphor. It is a value you can add, compare, and cancel with credit. Long before the minus sign, people tracked opposite directions. A merchant's ledger paired assets and liabilities. Owing more than you own is a state, not a riddle. Chinese mathematicians around 200 BCE used rods in 2 colors, red for positive, black for negative, to solve systems of equations. The idea was practical. Gains and losses belong in the same account. Brahmagupta, in 628 CE, gave negatives arithmetic. A debt plus a debt is a greater debt. A fortune plus a debt is their difference. He even stated that a negative times a negative is a positive, the rule that still puzzles students today. India treated negatives as numbers with laws, not as errors waiting to be deleted. Once negatives have rules, you can place them on a line. 0 sits in the middle. Positive numbers march right. Negative numbers march left. Every point is a position, not a lack. Distance from 0 uses absolute value. -4 and +4 are both 4 steps away. The line turns opposite directions into one continuous map. When Arabic and Indian ideas reached Europe, negatives faced skepticism. How can a number be below nothing? Cardano used negatives in algebra, but called them fictitious. Pascal argued comparing negatives was nonsense. Even Descartes treated negatives mainly as direction on a graph, not as quantities. Acceptance lagged behind calculation. Engineers used them while philosophers objected. Reality kept pushing. Thermometers dip below 0 Celsius. Mine shafts go below sea level. Bank overdrafts are negative balances. These are not poetry. They are measurements on a scale with a chosen 0. Once 0 means reference point, moving left or down is just as numerical as moving right or up. The number line models the world. Negatives gain power because every positive has an opposite that sums to 0. +5 and -5 cancel. That cancellation is why you can solve equations. Move terms across the equals sign by adding the opposite. 0 is the balance point. Without negatives, algebra loses half its moves. The symmetry around 0 is the whole game. Here is the surprise. Negative numbers were not invented because someone dreamed up less than nothing. They emerged because ledgers, climates, and equations needed opposite directions under one system. Europe debated whether they were real long after people were already calculating with them. The philosophy lagged the tool, again. Today, negatives anchor the coordinate plane. Left and down are negative directions. Complex numbers extend the line into 2 dimensions. Physics uses negative velocity to mean reverse direction. Computer graphics flips axes with negative scale. Remove negatives, and you lose symmetry, cancellation, and most of algebra. They are not edge cases. They are structure. Recap. Negatives began as debts and opposite-colored rods, not as abstract philosophy. India gave them arithmetic rules. The number line places them left of 0. Europe resisted the idea while using the calculations. Today they model direction, balance, and symmetry. Less than nothing was never nonsense. It was a number waiting for a home on the line. Negative numbers won because the world has opposites, and math needed a language for both sides of zero. Next time on Math Sketch, why the golden ratio keeps appearing in geometry and what makes phi unlike any other proportion. Subscribe for weekly pattern hunts. This is Math Sketch.